let's look at stretching and compressing the graphs of power functions. So we have k x to the p, where k is not 0, and we're looking at the graph. So we want to remember k is the coefficient. And that value of k affects what the graph is going to look like. So k is the coefficient. If k is bigger than 1, we're going to be vertically stretched. So looking at these parent functions, if we look at x cubed, when you make it 5x cubed or 10x cubed, it gets more and more vertically stretched. So x cubed is wider, but 5x cubed is more narrow, and then 10x cubed is even more narrow from there, because the coefficient out front is bigger than 1. You have 10 and 5, and those values are bigger than 1, and they're going to stretch out the shape of the graph. So vertically stretched if the power is bigger than 1, whether it's even or odd. So if we look at the parent function over here, x to the 4th, if we make that 5x to the 4th, the graph becomes more narrow. If we make it 10x to the 4th, it's even more narrow than that. So having a number bigger than 1 out front vertically stretches the graph. It's like we pull it up, it gets skinnier, is how we think about vertical stretch. Get skinnier or more narrow from having a coefficient bigger than 1 out front of the power function. It's going to be vertically compressed if we have a factor between 0 and 1. So something like 1/2, 1/3, 0.4, 0.75, something between 0 and 1, either a fraction or a decimal between 0 and 1, will make it vertically compressed. It's going to get wider. We look at our parent functions here without a coefficient, or just a coefficient of 1 out front, and we compare it to 0.5x cubed, it got wider. 0.25x cubed, even wider than that. Whether it is an odd power or an even power, having a value of a coefficient between 0 and 1 makes it wider. So x to the 4th gets wider when you have 0.5x to the 4th, and 0.25 is even wider from there. So we're going to vertically compress or make it wider. Vertically stretch or compressed by a factor of the absolute value of k is going to happen. So whether it's a positive or negative value, it's going to stretch or compress. So it's a -5, it's still going to make it stretched, but it's going to flip it across the x-axis. If it's -0.25, it's still going to make it wider. It's going to compress it, but it's going to be flipped on the x-axis. So having a number bigger than 1 makes it stretch. Between 0 and 1, it makes it compressed, but then if it's a negative, it also flips it across the x-axis. So if we think about an example, say x squared. Here's my x squared. If I make it a -2x squared, what's going to happen is the negative is going to flip it. So the negative flips. And the fact that we have 2 is either going to stretch or compress. So 2 is bigger than 1, so this is going to stretch. So how this would look, it would be flipped and skinnier. Something like this would be x squared compared to -2x squared. Will be skinnier and flipped along the x-axis. If it was -0.2, it would be wider and flipped on the x-axis. So that's how changing the coefficient affects the graph.